I'm trying to figure out if this converges or not. We've got to, well, let's see, we can't use the integral test. We've got n factorial, so that would mean like 10 factorial means 10 times 9 times 8 times 7, etc. So we can use our new ratio test. So the ratio test says take the n plus first term divided by the nth term, take the limit as n goes to infinity, and if you get something less than 1, it converges. So we need to figure out what this is equal to. So we need n plus 1, so we'll have the limit as n goes to infinity. So first of all you put a big fraction. First of all you put n plus 1 in for n, so that's going to be n plus 1 factorial in the numerator, and then 100 to the n plus 1. There's the numerator, a sub n plus 1. Now the function with just n. And since it's a fraction divided by a fraction, invert and multiply. So we've got the limit as n goes to infinity. This one would look like n plus 1 factorial over 100 to the n plus 1. And then invert and multiply, so this one becomes 100 to the n, and then n factorial. Series that have factorial, usually you'll end up using the ratio test. Sometimes a comparison test, but you can't integrate n factorial, so you're going to have to use something else. Ratio test usually works out pretty well. So if you look at n plus 1 factorial, so that would be something like you've got 11 factorial, and then down here you've got 10 factorial. Well, 10 factorial means 10 times 9 times 8, etc., all the way down to 1. 11 factorial means 11 times 10 times 9 times 8, etc., all the way down to 1. So in that case, this will cancel, 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 and finally the 1's cancel. All that you're left with is the 11, which is the number n plus 1. So we've got this, we'll divide into this and leave behind an n plus 1. Likewise over here, 100 to the n will cancel the 100 to the n, but it'll leave behind 100 to the 1. So then we have the limit as n goes to infinity of n plus 1 on top and then 100 on the bottom, and then that equals infinity, which is then saying the ratio of the terms is getting bigger and bigger and bigger. Or in other words, when you compare this one to this one is getting infinitely bigger than this one, which means the terms are getting bigger and bigger and bigger. If you go back to this, it's basically a battle between n factorial and 100 to the n. And you might think, well, 100 to the n, that means 100 times 100 times 100 times 100. That's going to be huge. That's a very powerful function. But n is going to infinity, so eventually it gets past 100. So imagine you get to 200. Then this one is going to say 100 times 100 times 100 times 100, 200 times in a row. This one is going to start with 200 times 199 times 198 times all of those 100s, 198, 197, they're all dominating this 100. When you get to 1,000, this is going to say 1,000 times 999. While this one is sitting here with its little 100s in a row thinking it's so powerful. Nope, n factorial wins the battle. That's really what this is saying. When you compare n factorial to the 100 to the n function, n factorial is this many times more powerful. Okay, so anyway, that means that it diverges. So this one from 0 to infinity, this one diverges because n factorial is so powerful. Another way to look at it, since n factorial is so powerful, is if you inverted it, if you had n factorial in the denominator, then because it's so powerful and you're dividing by it, it will make the fraction so small that it would converge.